Welcome to Context Window, your weekly look at the bleeding edge of AI coding tools. Let's see what's new. A major consulting firm, PwC, is reportedly making a 30,000-seat bet on something called a compute allocator, while tech observers are declaring HTML is the new Markdown in the context of AI coding. On the surface, those two statements might seem like disparate industry shifts.
They are, however, deeply connected by the evolving role of AI in software development. The shift away from Markdown for AI-generated code, particularly with tools like Anthropic's Claude Code, signals a move toward much richer, more interactive AI outputs, and that, in turn, requires sophisticated infrastructure to manage.
So this isn't just about AI spitting out plain text code snippets anymore. This is about AI delivering entire interactive user interfaces or even complete sandboxed applications?
Precisely. It's moving AI beyond mere text generation into what functions as an interactive development partner, capable of delivering rich, executable components directly within the AI assistant's interface. And that significantly changes the compute demands and how enterprises will integrate these tools.
So to unpack this idea of HTML is the new Markdown for AI. For years, Markdown has been the go-to for readmes, documentation, and even lightweight notes because of its simplicity. Why is it suddenly insufficient for AI-driven coding?
Markdown, by design, is a lightweight markup language. Its strength lies in its simplicity and readability for plain text and basic formatting. But when you introduce AI into the development loop, especially an AI that's supposed to be an advanced assistant, those limitations become very apparent. Markdown struggles with anything beyond basic text, headings, lists, and code blocks. It can't natively support interactive UI elements, complex styling, or embed executable components.
So if an AI generates a piece of code or even a suggestion for a UI component, Markdown doesn't offer a way to render that or let a developer interact with it directly within the AI's output.
Exactly. Think of it like this. Markdown is excellent for writing a recipe, but if you want a cooking assistant that can show you a video of each step, let you adjust ingredient quantities with sliders, and even simulate the cooking process, Markdown simply doesn't have the capabilities to do that. HTML, on the other hand, is the native language of the web. It's designed for rich, interactive experiences. It supports complex layouts, custom styling through CSS, interactive forms, and JavaScript for dynamic behavior. For an AI assistant, especially one focused on code, HTML allows it to output not just the code, but a visual representation of what that code does, or even a mini application that can be tested.
This means that AI isn't just generating code, it's generating a rich development environment or interactive components directly in its response. The original source mentions Anthropic engineers building with Claude Code. Is this a specific capability unique to Claude, or is it a broader trend we should expect from other advanced AI models?
While Anthropic's Claude Code is highlighted as an example, the underlying principle points to a broader trend. Other major AI providers are also pushing towards more sophisticated output formats. The goal is to reduce context switching for developers. Instead of an AI generating Python code that a developer then copies, pastes into an IDE, runs and debugs, an HTML-enabled AI can generate the Python code and a UI to interact with it, all within the same conversation window. This essentially turns the AI chat interface into a kind of mini IDE or sandbox.
That's a significant leap. It suggests that AI is becoming less of a simple code generator and more of an interactive development partner. The analogy of moving from a text editor to a graphical IDE for AI output makes a lot of sense.
It does. Consider the implications for error handling or debugging. If an AI generates code that has a bug, and it can also generate an HTML-based interface to highlight that bug or even suggest interactive fixes, it drastically accelerates the development loop. It's a move towards making the AI truly agentic in a development context, where it can not only propose solutions, but also demonstrate and allow interaction with those solutions.
So, the shift to HTML for AI output is about making AI-generated code not just readable, but actionable and interactive directly within the AI's response. This connects to the second, seemingly unrelated piece of the puzzle, PwC's 30,000-seat bet on a compute allocator. How do these two concepts intersect? Why would richer AI outputs necessitate a dedicated compute allocator for an organization like PwC?
The connection is quite direct. Richer, interactive AI outputs, especially those involving execution environments or sophisticated UI rendering, are computationally intensive. They require significant processing power, often GPUs and dedicated memory. For an organization like PwC, with potentially thousands of developers and consultants using AI tools, managing and distributing these compute resources becomes a critical challenge.
A compute allocator, then, is essentially a sophisticated resource manager for AI processing power. Is that the right way to think about it?
That's a good analogy. Imagine an entire fleet of powerful graphics cards and CPUs, some sitting idle, some maxed out. A compute allocator acts like a traffic controller or a dynamic scheduler for these resources. It ensures that when a developer or consultant needs to run a complex AI task, perhaps generating an interactive UI, running a code sandbox, or performing a data analysis with an AI model, the necessary computational power is instantly available. It allocates that compute on demand and then releases it when the task is done.
This isn't just about provisioning a cloud VM. This sounds like an intelligent system designed to maximize efficiency and minimize costs across a massive user base. 30,000 seats is a huge commitment.
It is. The scale is what makes this so impactful. For a smaller team, developers might simply have access to a few powerful machines or cloud instances. But at PwC scale, without an efficient allocator, you'd either have massive underutilization of expensive hardware or constant bottlenecks and queues for users. The allocator optimizes resource usage, which translates directly to cost savings and improved productivity across the entire organization. It's about elasticity and ensuring that the right compute is available at the right time for the right task.
So the richer the AI output, the more HTML-driven interactivity, the more sandboxing, the more critical a system like a compute allocator becomes. It's the underlying infrastructure that enables these advanced AI features to scale within an enterprise.
Exactly. If AI is to move beyond a niche tool for a few data scientists and become a ubiquitous assistant for every developer, every consultant, every knowledge worker, then the compute infrastructure supporting it needs to be robust, scalable, and highly efficient. PwC's investment in a compute allocator is a clear signal that they see this as a foundational requirement for enterprise-wide AI adoption. They're not just buying AI models, they're investing in the plumbing that makes those models practical and cost-effective at scale.
What does this mean for the individual developer or consultant working at PwC? How does this compute allocator directly impact their day-to-day workflow with AI tools?
For the individual, it means seamless access to powerful AI capabilities without having to worry about the underlying infrastructure. They wouldn't experience delays due to resource contention or need to manually provision machines. When they ask an AI assistant to generate a complex UI or to run a simulated environment, the compute allocator ensures the necessary processing power is instantly assigned to their request. It effectively abstracts away the complexity of managing GPU clusters or specialized hardware.
It's basically a utility service for AI compute, much like how electricity or cloud storage is consumed. One just expects it to be there when needed.
That's a very apt comparison. It turns AI compute into an on-demand, utility-like service for the end user. This reduces friction, accelerates experimentation, and ultimately drives faster iteration cycles for development and problem solving. This is crucial for large organizations that need to maintain agility.
This shift towards HTML and the reliance on compute allocators points to a future where AI isn't just a separate tool, but an integrated, interactive layer within existing development and operational workflows. It's not just generating code, it's helping build and run components.
It certainly suggests a deeper integration. Consider the implications for prototyping. A developer could rapidly iterate on UI ideas, have the AI generate the HTML and CSS, and then interact with a live preview, all within the AI assistant. This drastically compresses the time from concept to interactive demo. It also opens up possibilities for non-developers to create more sophisticated internal tools or data visualizations with AI assistance. The barrier to creating interactive applications is lowered.
And that ability to quickly prototype or even generate functional UI elements could profoundly impact enterprise-level application development. Think of internal tools, data dashboards, or bespoke client solutions.
Absolutely. For a firm like PwC, which deals with diverse client needs and internal tooling, accelerating the creation of such applications can be a significant competitive advantage. It allows them to respond faster, experiment more, and deliver more tailored solutions. The compute allocator is the engine that makes this possible at their scale, ensuring that this rapid iteration doesn't grind to a halt due to resource scarcity.
So it appears AI is becoming a more dynamic, interactive participant in the development process, not just a static code generator. This move to HTML for AI output and the enterprise investment in compute allocators are two sides of the same coin, addressing both the front-end experience and the back-end infrastructure required for truly scalable AI-assisted development.
That's a concise summary. This isn't just about new features. It's about fundamentally reshaping how developers interact with AI, how organizations manage AI resources, and ultimately how software is built in the age of AI. The enterprise is clearly leading the charge on figuring out how to make this practical and efficient at scale.
Looking at the larger industry landscape, how do these trends position companies like Anthropic, and how might competitors like OpenAI or Google respond to this push for richer, more interactive AI development environments?
Other major players can be expected to rapidly develop similar capabilities, if they haven't already, because the demand for deeply integrated, interactive AI in development is clearly growing. It's about providing a full-stack AI development platform rather than just a language model API.
It also highlights the strategic importance of what might seem like mundane infrastructure. The compute allocator is as crucial as the AI model itself for enterprise adoption.
Indeed. Many focus on the intelligence of the AI, but the practical reality of deploying it at scale often comes down to the efficiency and cost-effectiveness of the compute infrastructure. PwC's investment underscores that. They're betting that the combination of advanced AI capabilities and optimized resource management is the key to unlocking enterprise-wide productivity gains.
The evolution of AI coding tools presents a fascinating landscape. First, the move from Markdown to HTML in AI outputs signifies a leap towards interactive and executable AI-generated content, essentially turning AI into a more dynamic development partner.
Second, the massive investment by organizations like PwC in compute allocators reveals the critical infrastructure requirements for scaling these advanced AI capabilities across large enterprises, emphasizing efficiency and on-demand resource provisioning.
Third, the combination of these trends suggests a future where AI is deeply integrated into development workflows, enabling faster prototyping, reducing context switching, and potentially lowering the barrier to creating sophisticated applications for a wider range of users.
And finally, this points to a competitive landscape where AI providers must offer not just powerful models, but also comprehensive platforms that support rich, interactive experiences and scalable compute management to win in the enterprise market.
As these capabilities become more widespread, how might the roles of traditional software developers and even IT operations teams need to adapt and evolve?
And what implications might this have for the security and governance of AI-generated interactive code, especially when it's being executed within these new sandboxed environments?
That's all for this episode of Context Window. Join us next time for more on the AI tools shaping how we build software. If you're building with AI, subscribe. We cover what matters.
Ship smarter, not harder.